we have AP calculus AB problem. Okay, let's go with the information. Given f of x equals to 10 negative 16 over x, find all c in the interval 2 comma 8 that satisfies the mean value theorem. Okay, so before we start solving this problem, first let's understand what is mean value theorem. So for that, let me consider a function f of x which is continuous. Let me write the stuff over here. Say that the function f of x is continuous on the closed interval a comma b, and also say that the function f of x is differentiable. Let me write the stuff over here. So differentiable on the open interval a comma b. So when these two conditions are satisfied, that is the given function f of x is continuous on the closed interval a comma b, and it is differentiable on the open interval a comma b, then we can find a value c in the open interval a comma b, so that f prime of c equals to f of b negative f of a over b negative a. So this is the mean value theorem. So if I want to use the mean value theorem in our problem, for the given function, and find the value of c that satisfies mean value theorem. So what I have to do is I have to check the two conditions I have explained over here. That is function f of x over here has to be continuous on the closed interval 2 comma 8, and also it has to be differentiable on the open interval 2 comma 8. Okay, first let's check the first condition, that is whether f of x is continuous in this closed interval. So here when I look at the function f of x, so here we have x in denominator. So what if I have x equals to 0? When I plug in x equals to 0 here, so it will become undefined, then f of x will become undefined. That is, f of x is discontinuous when x equals to 0. So there is only one value of x, that is x equals to 0, for which the given function is discontinuous. So for any other value of x that is other than 0, the given function is continuous. Actually, in the given closed interval, we don't have 0, because from 2 to 8, if I consider any value from 2 to 8, so we don't get 0. So for all the values in the closed interval from 2 to 8, the given function f of x is continuous. Okay, so the first condition is satisfied. Now we have to verify the second condition, that is whether the given function is differentiable on the open interval 2 comma 8. So for that, what I have to do is I have to find the derivative of the given function. So for that, first let me write 10 negative. So to find derivative of this stuff, I have to move this x to numerator. So here we have x to the first power. Actually, we don't have any exponent for this x. Whenever we don't have any exponent, we have to assume there is an exponent 1. So to get derivative, I always have to move the variable to numerator. Okay, so when I move the variable to numerator, this exponent positive 1 will become negative 1. Okay, now I can find derivative. So f prime of x equals to, it's a constant. The derivative of a constant is 0, negative 16 times. Okay, 16 is a constant. It is multiplied by the variable. When I find derivative, so if there is a constant multiplied, I have to keep the constant as it is. When I find the derivative of this x to the negative first power, what I have to do is here I have to use the power law of derivative. That is, I have to bring this exponent in front of the variable. Let me take the exponent in front of the variable. Now I have to subtract 1 from the exponent. So this is the power law of derivative. So now I'm getting f prime of x equals to, so we can ignore this 0, and also negative 16 times negative 1 will become positive 16, x to the negative second power. So then we get f prime of x equals to, so here the exponent is negative. If I move this term to denominator, automatically the exponent will change its sign. That is, it will become positive. Then we get 16 over x square. Okay, now I got the derivative of the given function. So again, in the derivative also we find the variable in denominator. So the same thing what we have discussed for continuity. That is, if x is equal to 0, what will happen over here? So the denominator will become 0, then f prime of x will become undefined. That is, the given function is not differentiable at x equals to 0, but there is no chance for that, because we don't get the value 0 in the given open interval 2 comma 8. So from 2 in this open interval between 2 and 8, if I consider any value for x, I will never get 0. So there is no chance for this one to become undefined. So the given function is differentiable in the open interval 2 comma 8. Okay, since both the conditions are satisfied, now we can find the value of c in the open interval 2 comma 8. So that, using this formula, f prime of c is equal to f of b negative f of a over b negative a. Okay, now so let me write the stuff over here. Let me choose like f prime of c equals to f of b. So b is the right hand point of the given interval. So in our interval, the right hand point is 8. So we have to take f of 8 negative f of a means it's a left hand point, that is 2, over b negative a, that means 8 negative 2. Okay, now for f prime of c, what we have to do is already we know the result for f prime of x, that is 16 over x square. So if I want to get f prime of c, in the same result, I have to replace this x by c. Then I'm getting on the left side. Let me continue over here. So for f prime of c, what I can do is I can write the same result instead of x. Just I have to write c. So we get 16 over c square equals to. So to get the value of f of 8, what I have to do is I have to plug in x equals to 8 into the given function, because here we have f of x, at the place of x we have 8. So here also we have to plug in 8. Then I'm getting 10 negative 16 over 8 negative. To get f of 2, the same thing, I have to plug in x equals to 2 into the given function. Then I'm getting 10 negative 16 over 2 divided by, when I simplify this 8 negative 2, I'm getting 6. So 16 over c square equals to 10 negative. When I divide 16 by 8, I'm getting 2 negative 10 negative. When I divide 16 by 2, I'm getting 8 over 6. So 16 over c square equals to 10 negative 2 is 8. 10 negative 8 is just 2 over 6. Then 16 over c square equals to 8 negative 2 is 6. 6 over 6. Okay, so 16 over c square equals to 16 over 6, sorry, 6 over 6 is just 1. Okay, now what I'm going to do is I'm going to take reciprocal on both sides of this equation, because I'm trying to solve for c. So, but the c is in denominator. So to get the c to numerator, I'm taking reciprocal on both sides. When I take reciprocal for 16 over c square, I'm getting c square over 16. So on the right side, when I take reciprocal for 1, still I'm getting 1. Okay, now I multiply both sides by 16 to get up the denominator 16 on the left side. So 16 will cancel out. I'm getting c square equal to 1 times 16 is 16 on the right side. Okay, now to solve for c, I have to get up this square. For that, I have to take square root on both sides. When I take square root on both sides, so for one of the square roots, I have to consider positive or negative sign. So usually you consider positive or negative sign for the square root which contains number inside it. So here this square root contains number 16 inside it. So we can consider positive or negative sign. So the square root and square will cancel on the left side. C equals to positive or negative. So the evaluation of 16 is just 4. So I am getting two values for C. One is C is equal to 4 and the other value C is equal to negative 4. So according to the mean value theorem, the value we get for C has to be in the open interval. So open intervals mean like we have a closed interval in the given question, we have to change it to the open interval. So here we have 4 and negative 4. So we have to check which one comes in the open interval of 2, 8. So clearly 4 is the value we have in the open interval 2, 8, because at any chance the negative value we have in this open interval, because from between 2 to 8 all the values will be positive. So we can ignore the second value of C over here. So therefore C equals to 4 in the open interval 2, 8. For the given function, the value of C in the interval 2, 8 that satisfies the mean value theorem is 4.